Earth is not special. I know, that stings. We grew up believing our planet was a cosmic miracle, the perfect blue marble uniquely suited for life. And sure, Earth crushes the competition in our solar system. Mars is a frozen desert. Venus is a 470-degree pressure cooker. The gas giants would flatten you instantly. But that's like being the best basketball player in a kindergarten class. You win. The bar was on the floor. The truth is, Earth is aggressively mediocre. And scientists have figured out exactly what a truly great planet would look like. They call it a superhabitable world. A planet so perfectly engineered for life that Earth is a fixer-upper with good bones and terrible everything else. So let's build one. Let's design Hestia, named after the Greek goddess of hearth and home, the best possible planet for life in the universe. At every step, we'll compare it to the planet you're sitting on right now. Spoiler, Earth loses, repeatedly. Let's begin. First, the star. Because a perfect planet needs a perfect sun, and ours is already failing. The sun is a yellow dwarf, and yellow dwarfs have a fatal flaw. They die. In about 5 billion years, it will swell into a red giant and swallow Earth whole. But the real problem is already happening. Yellow dwarfs get hotter as they age. The sun has brightened 30% since it formed. 70% of the window for complex life on Earth has closed. We have maybe 1 billion years before the oceans boil away. Earth is living on borrowed time. Red dwarfs make up 70% of all stars and live trillions of years, basically forever. But their habitable zones are so close that any planet gets tidally locked. One side an eternal furnace, the other frozen forever, and young red dwarfs vomit flares of deadly radiation that sterilize everything nearby. They have the lifespan but not the temperament. They're the universe's most patient murderers. The perfect star sits between them, an orange dwarf, K-type main sequence star, if you want the technical term. Orange dwarfs are remarkably stable. Their energy barely flickers over tens of billions of years. Their radiation is gentle. And they live up to 70 billion years. Long enough for life to emerge, evolve, get wiped out, re-emerge, and build civilizations that make our 10,000-year experiment look like a weekend. So here is Hestia's sun. An orange dwarf born 3 billion years ago in a quiet galactic neighborhood. It will remain perfectly stable for billions of years. It doesn't have a midlife crisis. It just glows warmly and reliably like the universe's best space heater. Earth's sun, dying, getting hotter, has burned through most of its useful life. Earth loses. Now the planet itself. Hestia is a super-Earth. 1.3 times Earth's radius, 70% more surface area, nearly twice the mass. Walking its surface, you'd feel 20% heavier. Not crushing, just substantial. Like wearing a backpack full of groceries, your muscles would adapt. You'd get used to it. But size alone means nothing. Mars was once Earth-sized with oceans and an atmosphere. Then lost its magnetic field. Without that protective shield, solar winds stripped the atmosphere away, atom by atom. The water boiled into space. The core cooled and died. Mars is a frozen gravestone warning every planet designer. Don't skip the magnetic field. Deep inside Hestia, we install a massive metallic core, spinning in a liquid mantle, generating a magnetic field of exactly the right strength. This shield deflects solar storms and cosmic radiation around the planet like an invisible fortress. The atmosphere is protected. The surface is safe. Hestia also needs plate tectonics. Earth has them, credit where it's due. Venus doesn't, and look what happened. Without plates to release pressure gradually, Venus built up unimaginable stress, then cracked open in a global volcanic cataclysm that turned the entire surface into a 470-degree hell where lead melts. No plate tectonics means you're a ticking bomb. Hestia's plates slide, collide, and dive continuously. At subduction zones, they pull excess CO2 out of the atmosphere. At mid-ocean ridges, they push up fresh minerals, phosphorus, potassium, nitrogen, that life feasts on. The crust recycles itself like a self-cleaning oven from which new continents emerge, fresh and fertile. Earth wins this round by technicality. It's Earth's only clean victory in the entire comparison. Don't get comfortable. The next rounds are brutal. Now the surface. And this is where Earth starts embarrassing itself. Earth has a continent problem. Most land is locked into a few enormous supercontinents. Their interiors are far from water, receiving almost no rainfall. The result, deserts, vast, hostile dead zones, the Sahara, the Gobi, the Australian outback, beautiful from space, worthless for life. On Hestia, we fragment the continental plates into dozens of pieces that can never merge into supercontinents. Hestia becomes an archipelago world, millions of islands of every size, scattered like shattered stained glass. Every piece of land, no matter how small, has access to water. Rainfall reaches every corner. There are no deserts. Not one. With 70% more surface area and all of it habitable, Hestia has vastly more living space. Earth has 29% land, much of it frozen or arid. Hestia, maximum coastline, accessible land, zero wasted real estate. Earth loses. Badly. Time and rhythm. On Hestia, we set 36-hour days, 18 of gentle orange daylight, 18 of star-filled night lit by 4 small moons. Longer days extend growing periods. Longer nights drive evolutionary creativity. We tilt the axis gently, just enough for mild seasons that create migration and evolutionary pressure, not enough for uninhabitable extremes. No freezing winters. No scorching summers. The poles stay ice-free, covered in temperate forests circling the globe in an unbroken ring of green. And those 4 small moons aren't decoration. With the right orbital resonance, they lock Hestia's axis in place, preventing the chaotic wobbles that could flip a planet on its side. The seasons stay stable for billions of years. Temperature. Earth averages 15 degrees Celsius, but that number hides a brutal distribution. Enormous regions are frozen most of the year. Boreal forests, tundras, ice caps, biologically barren for months at a stretch. Only the tropics, maybe 15% of Earth's surface, offer ideal year-round conditions, and tropical rainforests alone hold more biomass than every other land ecosystem combined. A thin green ribbon around the equator contains more life than all the forests, grasslands, and tundras stretching to the poles. We make Hestia 5 degrees warmer. That's it. Suddenly the entire planet is tropical, ice-free poles. Every square meter bask in life-friendly conditions year-round. Hestia is rainforest from pole to pole, an unbroken belt of vegetation across every island, every latitude. One consequence, under an orange dwarf's redder light, Hestian plants don't use green chlorophyll. They evolve darker pigments, deep purples, near blacks, rich crimsons, to capture every photon. Walking through a Hestian forest, walking 3 above is not green. It is dark purple and midnight blue, veined with amber, filtering orange, sunlight into a perpetual sunset. No forest on Earth has ever looked like this. Earth's temperature, mostly frozen, life compressed into a narrow tropical band. Earth loses. Now the atmosphere. Hestia's larger mass holds gases tighter, creating an atmosphere 1.5 times Earth's pressure, with around 30% oxygen, way above Earth's 21%. On Earth, this would trigger catastrophic wildfires. But Hestia is so humid that rain extinguishes any fire within minutes. The oxygen is safe, and the benefits are staggering. More oxygen means more energy per breath. Animals grow larger, metabolisms run hotter, predators hunt with explosive speed. Prey flee with athletic dynamism, the entire predator-prey arms plays at a higher tempo, generating more diversity with every million years. And flight. On Earth, flight is brutally expensive. Birds burn 10 to 15 times their resting energy just to stay airborne. Insects can't grow large, their breathing systems fail at scale. The largest flying creature ever, Quetzalcoatlus, pushed against the absolute limit of what thin air permits. On Hestia, flight is practically free. The dense atmosphere buoys creatures upward. Animals need to grow enormous, beetles the size of cats, dragonflies with meter-wide wingspans, 4-legged insect megafauna that dominant evolves independently across thousands of lineages until the sky becomes an ecosystem as rich as the land. Sky whales drift through cloud layers, filter feeding on dense clouds of airborne organisms. They are born aloft, live aloft, mate on the wing, and touch the ground exactly once, to lay an egg on a mountain peak before ascending forever. When they die, their bodies descend like gentle meteors, fertilizing the forests with a lifetime of nutrients. A sky whale fall feeds hundreds of species before the carcass even reaches the ground. And sound. In this dense atmosphere, sound carries farther. The planet is never quiet. Calls, warnings, and mating songs vibrate through the air across entire islands. Some predators have abandoned stealth for sonic warfare, masking their approach with disorienting multidirectional noise that makes it impossible for prey to locate the attack. Earth's atmosphere. Thin, flight is a metabolic marathon, insects are tiny, the sky is empty, Earth loses. The oceans. Earth's oceans are a design disaster. Average depth, 3,700 meters. Sunlight penetration, 200 meters. That means 90 easy dive. TT ocean is dark Arthur pressure abyss where almost nothing lives. The entire barren spectacle, reefs, fish schools, whales, plankton blooms, is squeezed into a thin illuminated skins. Earth's oceans are a mansion where only the vast dead void. Earth's oceans are a mansion where only the foyer has lights. Hestia's oceans are almost entirely shallow. Continental shelf depths between 1 and 200 meters. Every drop is a sunlight zone. Phytoplankton blooms from coast to coast. The entire seafloor is bathed in dim orange light, supporting photosynthetic life across the entire ocean. Coral reefs become megacities, living structures stretching thousands of kilometers. Pseudocrabs, fish lizards, creatures with no evolutionary analog on Earth compete for every centimeter of real estate. Bordering the coral cities are vast kelp forests, thick as jungles, filled with animals navigating fronds like monkeys in trees. And the coastlines. Even on Earth, coastlines hold more than half of all marine species while occupying just 7% of the ocean area. The interface between land, sea, and air is the richest habitat on any planet. Hestia's coastlines, with millions of islands creating fractal edges, are 45 times longer than Earth's. That's not a percentage improvement. That's a different category of planet. Hundreds of millions of species. More life in one Hestian bay than in all of Earth's oceans. Earth's oceans deep, dark, mostly dead. Earth loses, spectacularly. Zoom out. Earth hosts roughly 9 million complex species. 9 million. Hestia, with its larger habitable surface, endless tropical archipelago, thick oxygen atmosphere, shallow sunlit seas, and 45 times longer coastlines, could hold hundreds of many. 100 times. Hestia isn't a better Earth. It's what Earth is to Mars, a different class of object entirely. And this brings us to the deepest question. Intelligence. Us. Earth produced one technological civilization in 4 billion years. It took the entire window. Anatomically modern humans appeared 300,000 years ago. Agriculture began 12,000 years ago. We've been spacefaring for 60 years, and we nearly wiped ourselves out multiple times in the last century. On Hestia, with its staggering diversity of ecosystem parallel evolutionary experiments, intelligence might not be a fluke, it might be a pattern. Imagine 3 intelligent lineages evolving simultaneously on different archipelago continents, isolated for millions of years. A cephalopod analog building cities of carved coral, communicating through light patterns too fast for human eyes. A sky whale descendant, enormous flying philosophers, with centuries-long lifespans, developing mathematics based on fluid dynamics. And something closer to us. A terrestrial tool user with fire and telescopes. They'd eventually meet. The encounter would be the most significant event in either species' history. Communicating with a mind from a completely different tree of life, a mind that experiences time differently, conceptualizes self through alien categories. What would they think if they found Earth? A cold, mostly frozen world with enormous barren deserts, deep empty oceans, a dying yellow star, and one intelligent species that fights wars over imaginary lines. Would they pity us? Cross Earth off their survey and move on? File us under failed experiments, check back in 1 million years? Or maybe they'd see something invisible from the inside. A species that, despite every disadvantage handed to it by a mediocre planet, a dying star, and its own worst impulses, kept going, invented fire against the cold, built boats against the oceans, built rockets against gravity, kept asking questions, even when the answers were terrifying. Here's the thing. We don't know if Hestia exists, but among the quadrillions of planets in the universe, the odds that at least one is a superhabitable world orbiting a calm orange dwarf approach certainty. Somewhere out there, there is almost definitely a planet that makes Earth look like a rough draft. A world hosting more life at this moment than our planet has in its entire history. And yet, Earth, for all its mediocrity, all its frozen wastes and scorching deserts and deep dead oceans and ticking clock sun, is the only planet that produced you. The one world where you and I exist at the same time, in the same moment, wondering about the same stars. Hestia may have more life, but it doesn't have you. Earth is not special, but you are. And maybe that's what the universe has been waiting for all along,